Hey, I made a quick video here so we could go over just a couple more things about simplifying square roots. This tends to be a little tricky for kids at first, so sometimes it helps if you get some feedback right after the lesson and you can kind of see what's going on. So I have three problems I want to work through in this video. That's it. Take notes, and it might be a good idea to pause the video and try it yourself before I go any further. Anyway, I was going to start out by simplifying the square root of 108. And 108 has a lot of different factors, but most commonly kids will look at this and say, well, since 108 is even, why don't I split it up into 2 times 54? Now remember, when we're trying to simplify a number inside a square root, we want to break this number all the way down as far as we can. Now 2 can't be broken down any further, so I'm going to just bring it down. But 54 can be. And when I take 54 and I break it down, I get, well, 9 times 6 would work. Now you could break 54 down into a bunch of other factors. You could do 2 and 27, but it doesn't matter. We're still going to end up with the same bottom line here. Now, one thing you'll notice is that I did take this 2 and I brought it down. Some of you, when you were doing some work the other day, I noticed you were leaving it up here. Don't leave it up there. It's a factor. It needs to come down. So this 2 will come right down to there. This 9 I'll break up into the only two things, 3 times 3. And this 6 I'll break up into the only two things, 2 times 3. And now that we have all of our number inside the square root, now that we've broken it down as far as we can, we're going to start looking for some twins. And so as I look for twins here, I notice, let me grab a highlighter, I notice that we have a 2 in square root prison and another 2 in square root prison. We have a 3 in square root prison and another 3 in square root prison. And remember, we're looking for twins. So what I see here is that this radical 2 here and this radical 2, they can escape. One of those radical 2's gets out and is free. The other one doesn't make it. Pair of radical 3's, one of them gets out right here. One of these will get out and escape. The other one doesn't make it. And look who's left behind, a radical 3. So now when you finish this problem, outside the square root we have 6. Inside the square root we have a 3, and that would be 6 radical 3. Okay? Now that's a basic simplification. And it can get a little trickier for us. Like here's a problem right here that's a little bit trickier for us. So our first inclination is, going back to algebra, we think about, gosh, if I had 5x and I subtracted 7y, there's really nothing you can do to simplify these because they don't match. And similarly, over here you have 5 times something minus 7 times a different something. And your first thought is, well, they don't match, I can't combine them, I'm already simplified. But that's actually not the case, because this radical 24 can be simplified. So let's start this problem out here by breaking down what's inside the square roots. Now I have a 5 hanging outside the square root, so that 5 is going to stay. And I'm going to factor 24, and I'm just going to choose 6 times 4. You could do 3 times 8 if you wanted to. You could do 12 times 2, but I just chose 6 times 4. Now over here we have a minus 7 times, and for 54, I'm going to choose 9 times 6. Again, you could choose your own factors. It won't matter in the grand scheme of things. Now, I still can break down a little further. Of course, we still have this 5, which is here. This 6, this radical 6, I'm going to break down into radical 3 times radical 2. This radical 4, I'm going to break down into radical 2 times radical 2. Now, just to be clear, this whole expression here came from just this expression. which in turn came from this expression. That's just the left side of my expression, where that 24 is fully factored into 3 times 2 times 2 times 2. Now, the right side, this, is going to be broken down into that. And we can take this a little further. We have a minus 7. I can take that radical 9 and break it down into radical 3 times radical 3. And I can take this radical 6 and break it down into radical 3 times radical 2. Again, this entire expression that I underlined in green comes just from the second half. So, let's do the order of operations. We've got to handle the multiplication before we handle the subtraction. Over here on the left-hand side, I do see a pair of twins. Boom, there they are. Pair of twins. What's that mean? Well, we have a 5 that's already out. A pair of twins, one of those 2's gets out, the other one doesn't make it. And what's left behind? What's left behind is a radical 6, a radical 3 and a radical 2. That makes radical 6. Over here, in the green part, I see a pair of 3's in square root prison. So what's that mean? Well, we still have our minus 7. Pair of 3's, one 3 gets out, the other one doesn't make it. And left behind is a 3 and a 2 in square root prison, which forms a radical 6. Cleaning up, 5 times 2, that's 10 radical 6. 7 times 3, that's 21 radical 6. Now, it turns out that even though initially we didn't think that these two things matched, they do. They do match. They are like terms. So I can take 10 of something and subtract 21 of that same something and get negative 11 of that something. And those are pretty tricky problems. I mean, there's a lot involved. You have to factor and keep track of every little factor. You have to get your numbers to escape and clean up, and then finally you have to combine like terms. There's a lot going on there. The last one I want to look at is this problem up here. Now, notice we're not adding or subtracting, we're multiplying. So the very first thing I want to do is since multiplication is not as finicky as addition, I can just multiply any numbers together, whether they look the same or not. Multiplication will just take any number and put it together. I am going to look at this radical 6, and I'm going to break that radical 6 down. I think we can break that radical 6 into radical 2 times radical 3. And over here, and again, all I'm doing is I'm taking this radical 6, and I'm breaking it down and keeping the 5 there. Over here, we have a 10, and it's just times radical 3. Now, I have this gigantic expression. Let's see what we have. Well, okay, I have 5 times 10, which is 50. I have a radical 3 here and a radical 3 here. We can form a jailbreak. One of those 3's is going to get out. The other one, oh, doesn't make it. And left behind is that radical 2. So what's the final answer? Well, the final answer is 150 radical 2. And when you're all done with this, you can go ahead and get the review problems and get those started. You should be able to get through most, if not all, in class. Good luck.